All right, today we want to look at limits at infinity, and there's two types. The first one's one like this. The limit is x goes to infinity of something. And then the other kind is where our actual answer of the limit is infinity. Now, we've looked at this a couple times already. Sine of x over x. We said the other day, what was our limit of sine of x over x? It equaled 1. That was if the limit was to 0. And then we looked at it by table of values. We looked at it by graphing it. We did sandwich theorem to kind of prove it. But if it's going to 0, we said it's 1. But what happens if it's not going to 0 is it's going to infinity? That changes our limit. Now think about what this limit does. And one of the things that's going to be interesting about today, today is a lot of like mental reps, not physical reps. And what do I mean by that? You're not going to see a lot of work written down, but you just got to kind of in your head think through it. This is an example of that. What we have to do is say, okay, what happens on the bottom? As x goes to infinity, this kind of becomes infinity, right? Which infinity just means a really big number. And what happens to sine? Does sine go to infinity? When you think of the graph of sine, it is always between -1 and 1, right? Yeah. So you think this is some number, and it's between -1 and 1. So what happens when you basically have some number divided by infinity? What happens when you have a number divided by a really, really, really big number? Like, think of the biggest number you can think of, and then make it square it. Big number, right? So what happens there? Well, if we just look at it, like if we have a calculator up here, I can get my calculator to open up. What happens if you take some number and you divide it by a really, 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 really big number? What happens to it? It gets small, right? So if we look at my calculator here, if I take some number, 0.5, right, some number between -1 and 1, and I divide it by a really big number, I'm going to get a really small number, right? So in terms of the limit, what this means is it goes to 0. It gets really small. Okay. So that's one kind of limit, and we're going to look more at that later in this chapter, and we will flesh out this idea more. Today, we want to look at, though, not that x goes to infinity, but what happens as x goes to a number, and our answer is going to be infinity. Okay? So as we look at this, we want to look at the limit of 1 over x minus 2 as x approaches 2 from the right. Okay? So, what's going on here? Well, if I put 2 in, what do I get? 1 over 0. Well, let's go back to our calculator for a second. What would happen if I did 1 divided by 0? You guys are smart enough, you've done this long enough to know, can you divide by 0? No. You're going to get an error. Okay? Now, what happens if we take 1 divided by, understand our limits, okay? Let's back up for a second. What's our definition of a limit? The limit of f of x as x approaches c equals L if, go.
Can you say it again?
It's the limit of f of x. So we have the limit of f of x as x approaches c, is equal to L if, and we can write it as notation or in words, either way, if what? What's the next part?
There's a f
epsilon greater than 0.
Okay? It was, the important word was for any epsilon greater than 0. Or if we wrote it with symbols, it was for all epsilon greater than 0. Okay, that's the first part. What's the rest of it? Keep going. For any epsilon greater than 0.
The other.
It's like the upside down thingy we're doing. What's it called? Does it start with a D?
We first need to say there exists a what? What'd you just call it? You gave it an interesting name.
I said it started with a D, didn't it?
And what's we said the
Upside down.
upside down what? You said something upside down what?
I don't know.
I don't know what you just said.
I don't remember either.
Is that the D thing? Delta.
Yeah.
That's delta. So for any epsilon greater than 0, there exists a delta greater than 0. What's the next words? Such that if x minus c is less than delta, then f of x minus L is less than epsilon. There's our definition of a limit. So notice though here, a few things I want to point out that maybe we haven't mentioned exactly. Do you actually does x ever get to c? Does x ever equal c? Because if x equaled c, what would x minus c be? 0, right? And it's not 0, it's got to be something greater than that. So think about, let me back up. Think about if we did this. And I'm just going to, when we talk about evaluating that limit, like we did, you put 2 in, you get 0 over 0. So 0 over 0 means, what does 0 over 0 mean? More work. And in this case, our more work here is we would factor this, right? Cancel those, put the 2 in, and get 4, right? So we'd say that's equal to 4. But in this fraction, if we just look at this part here, can you put 2 in to that fraction? No, because 2 makes it 0 on the bottom. You can't divide by 0. So you can't plug 2 in. It's undefined. However, the idea of a limit is what? As x gets closer and closer and closer and closer and closer and closer and closer to 2, this fraction gets closer and closer and closer to 4. Does that make sense? So we're not actually putting the number in, right? I'm trying to get us to understand what our limit is here. Let me go to a calculator. So if we would go here and I would say x squared minus 4 divided by x minus 2, and we can't put 2 in because it gives you an error. But if I put a number in for 2 really, really close to 2, what's my answer going to be? Really close to 4, because that was what the limit was, right? And as my number gets closer and closer and closer to 2, my answer gets closer and closer to 4. That's the idea. It's not exactly 4, but it's close to 4, right? And then we also know we have to consider both ways to, right? That's the idea. We're not saying if you put 2 into this fraction, it equals 4. You can't put 2 in. It's undefined. What we're saying is as we put a number in really close to 2, we get an answer really close to 4. Well, How close? Well, you can have different ideas of what close means, right? So the mathematical way of doing that is to say, no matter how close you want to be, that's my epsilon. No matter how close you want to be to 4, I can find a number that close that will get, that's the whole idea of what the epsilon delta stuff is, okay? So we are not saying we're actually plugging 2 in. We're never saying that, because if you plug 2 in, it's undefined. We're saying if you plug a number in really, really, really close to 2, your answer is going to be really, really, really close to 4, okay? Just trying to, big picture here, okay? So, it goes back to here. So, we can't plug 2 in exactly because we get 1 over 0, which is undefined, can't do it. But the whole idea of a limit is if we plug numbers in really, 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 really close to 2, this gets really, really close to 0, right? Now, if you're approaching from the right, are the numbers you're plugging in that are bigger than 2, are they bigger than 2 or less than 2 if you're approaching from the right?
Bigger.
They're bigger than 2. So now you are taking numbers like 2.2, 2.1, 2.01, 2.0001, 2.0000000001, right? So when you subtract those, this is not really 0, it's just a really small number. But isn't this a positive number? Now, compare that down here. This is also 1 over 0. But down here, you're putting in numbers from the left. 1.9, 1.99, 1.9999999. And when you subtract that from 2, it's getting close to 0, but it is a negative 0. Now, if we go back to our calculator, as we said, if you take 1 divided by a really small number, what do you get? A really big number. So, 1 divided by a really, 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 really small positive number is going to give me a really, 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 really big positive number. So that's going to infinity. 1 divided by a really, really big negative, or really, really small negative number, this is going to go to negative infinity. So that is algebraically how we're doing that. Now, let's help us understand. Let's go back to the calculator. Let's go here. And let's look at the graph of 1 divided by x minus 2. As I approach 2 from the right, where does my graph go? To infinity. From the left, as I approach 2, it's going to negative infinity. The same thing that we get from here. Now we want to understand how to do this without just looking at the graph, but we want to understand that, okay? All right. So another one. I think there's a typo. Nope, your paper's right. There was a typo on my notes here. So, we're looking at the, oh, hold up, let's back up. Hold up, I want to talk about something. Let me go back to here. Let's say I asked you this question. What's the limit as x approaches 2?
Just infinity,
Why?
because it's still a positive number, right?
Well, this is just
Come from the right.
at 2. Think about this in reference to Bob. What does theorem Bob say?
The positive and negative are the same, so then, wait,
If the limit from the right equals the limit from the left, then the limit at the point has to be the same thing, right?
yeah,
So is our limit from the left equal to our limit from the right? Up here. Is our limit from the left equal to our limit from the right? One's going to infinity, one's going to minus infinity. Are they the same? If you look at the graph, from the right and the left, are they the same?
no,
No. Therefore, this does not exist. Because the limit from the right and the limit from the left aren't the same. Okay. All right, let's try this one. So what's the limit as x approaches negative 3 from the right and negative 3 from the left of 2x over x plus 3? So both of these, the bottoms go to 0. What's the top get close to? As x approaches negative 3 from the right, 2x gets close to what? Negative 6. In both cases, right? This is bigger than negative 3, so this is approaching negative 6 from the right. This is approaching negative 3 from the left, so this would be less than negative 6, so it's approaching negative 6 from the left, but they're still both approaching negative 6. Now what about the bottom? Is this 0 on the bottom a positive or negative 0? So what you want to think about is think about negative 3. If you're approaching from the right, think of a number over there. What's to the right of negative 3?
negative 1.
Negative 1. Right? Yeah, you could go like negative 2.99 or whatever, right? But that's more complicated. So just go negative 1. What's the number over here? Negative 4, right? So think about if you put negative 1 in here for x. Is that number positive or negative?
Negative. Wait, oh,
Positive.
Positive. If you put a negative 4 here, that is negative. So when you're trying to figure out if the 0 is a positive or negative, just pick nice whole numbers on either side to just do the quick math. Instead of, yes, you could think, okay, if this is negative 2.9, 2.9999999, that's getting closer. That's going to be less than 3. So when I add 3, I get, or just pick negative 1. It makes the math much easier, right? So now, if you have a negative number divided by a really, 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 really small positive, what's your answer? Like I said, we want to understand this without using the calculator, but I'm doing the calculator to help us understand what's going on. If I take a negative divided by a really, really small positive, we get a really big negative. That's negative. If I have a negative divided by a really, really small negative, negative over negative is positive. All right. Flip it over in the back. Does that limit exist? No, because the right and the left are different. All right. Try a few more. Try that one. Function is 1 over x minus 1. Try to find the limit as x approaches 1 from the left and the right. Give you a second to try that. All right, so what do we get the first one? Limit, well, turn to each other, like count of 3, and tell the person what you got, and then we'll share it up here. Ready? 1, 2, 3, go. What'd you get? You guys agree?
Yep.
So what'd you get for the first one?
Negative infinity.
Negative infinity, and the bottom one?
Or, yeah.
Yeah, infinity.
This infinity on the bottom? Got that? Okay. So both of these are 1 over 0. Right? And you're approaching 1 from the right and the left, and I'm just going to say let's pick 0 and 2. So when I approach 1 from the right, I put 2 in there. 1 minus 2 is a negative, so that's negative 0. 1 over negative 0, negative infinity. And then the opposite here is that. And understand, when I am talking about plus or minus 0, maybe we should almost put it there. It's not the same thing as approaching from the right and the left in a limit. Does that make sense? We're just saying 0 is a positive number and 0 is a negative number. Okay? All right. Let's talk about a vertical asymptote. The definition of a vertical asymptote of a graph of f of x is this. If you approach a number from the right or the left, and it goes to plus or minus infinity, that is the definition of what a vertical asymptote is. So the line x equals a is a vertical asymptote of the graph if either of these two limits exists and is equal to plus or minus infinity. And we kind of already seen that when we looked at this graph, right? So you approach from the right, it goes to infinity. You approach from the left, it goes to negative infinity. And that means we have a vertical asymptote right there. When we looked at it before, we said, previously when we looked at these, we said, oh, you can determine a vertical asymptote by where the bottom is 0, right? So if you think in pre-calc, we would determine a vertical asymptote by where the bottom was 0, right? Now, using the limit, we can actually determine not only where the bottom's 0, but as we approach from the left or right, which way is it going? Is it going up? Is it going down? Or whatever. We can determine that from using our limit. Okay. So let's look at this one. The limit of f of x as x approaches 3 from the right and the left. Okay. These are not necessarily your notes. I'm just going to hit a few more examples on the back here to help us kind of, we can write them down. So as we approach, once again, both of these are 1 over 0. The thing we got to decide is it a positive or negative 0? So we can say we're approaching 3. From the right is 4. From the left is 2. To kind of think about it. So if we plug 4 in for x, what do we get? 4 minus 3 is positive, right? So this is positive. We're going to infinity. What happens if we put a 2 in there? 2 minus 3 would be a negative, but because it's squared, it's positive. So you get that. So notice now, do I have a limit at 3? By Theorem Bob, the left and the right are equal. So this is the same. It goes there. Let me show you the graph. So how you can maybe picture what that's going to look like if we do that. Oh, I got to get rid of that. So well, it's about the same place. Pretty good. So can you see now how you saw the vertical asymptote, but from both sides they're both going up? So that means that you now have the limit at 3 because you don't have one side going one way, one side going the other. Okay. So you got space on the back? Let's put 2 more down here we're going to try. Try those 2. Write them down. Try those 2 and then come back and look at it. All right, so what do you think about the first one? Tell me your thoughts.
Didn't like it.
Why?
Wasn't easy.
What happens when you put in -1?
Bottom gets 0.
Bottom goes 0. What about the top?
-1. Wait.
0.
You get 0. This is 0 of 0. So if we factor that like that, and you plug negative, oh, there should be a negative there, sorry. -1 in, what do you get? 2. And this one, the fact that's from the right does not matter because the x plus 1 cancels out, right? So it doesn't matter. What about the second one? On the second one, when you plug in 2, you get 0 on the bottom, 3 on the top. So what about the bottom? Is it from the right or from the left? So is it a positive 0 or a negative 0? You don't know. So if it was a positive, you'd have a positive 0 go to infinity. If it was from the left, you'd have a negative 0 goes to negative infinity. So if the left and right are not the same, what happens at 2?
Not exist.
It does not exist. Okay. So anytime you have, here's the takeaways. Anytime you end up with 0 over 0, that means more work. And usually what that's going to mean is you're going to factor and you're going to cancel something out. Anytime you end up with a number over 0, then you have to look and see, is it from the left or the right? And if your left and right are different, the limit doesn't exist. Okay. So if we think about, finish up with this one thing here that we talked about at the beginning, and we're going to get into this more later. If you have a number over 0, right, you have to know if the 0 is plus or minus. And then this is going to go to plus or minus infinity, depending on the sign, SIGN, of the 0 and the number. If we have a number over infinity, like we started, that is going to go to 0. That is a good rule of thumb. That would be good. Like put that on the front of your notes somewhere to help you remember that. So if you have a number over 0, it's going to plus or minus infinity. Which one is it? It depends on if the number and the 0 are positive or negative, right? If they're both positive, it's going to positive infinity. If it's one positive, one negative, it's going to negative infinity. If they're both negative, it's going to positive infinity. When you get a number over infinity, that's going to 0. And it doesn't really matter what the signs are, S-I-G-N again, because it's going to 0 either way, and it doesn't truly matter. Okay? All right.